Now that we've covered the Android SDK and Android Studio, we would like to turn to a very practical application of what we've learned. That is, we are going to create and build a location-based weather app that will give us the weather based on our GPS location. Then we will go through some of the tools in Android Studio showing their use with the weather app as a backdrop. So let's get started. Let's create our first app, the weather app. We're going to learn how to build apps by creating one right now with Android Studio. To do this, we will start Android Studio. It will display the option to start a new Android project. Clicking on it, we will name our app Weather App. Give it a company domain. It will act as a package for the application. Here, it's named as training.eduonix.com. Now, we will select the project location where the project will be saved. We will call it Workspace. Clicking Next, we have to select the target device that we are going to develop the app for. We will also select the API level that corresponds to our version of Android. Now, there is a view where we can select an activity for the app which gives options like no activity, blank activity, etc. We are selecting blank activity for our sample app. Clicking on Next, we will give the activity name here as Home Activity. We will also give it a layout name, title, and resource name. We will discuss each of these components in detail while going through the app development. Clicking on Finish, we can see the Android app is now set up. We have successfully created our first Android application using Android Studio. Before Android Studio, developers were using different IDEs to build Android apps. The most popular of these is Eclipse. The good news is that you can import an existing Eclipse project into Android Studio so that the work is preserved. We'll go over the various steps to doing this. Migrating from Eclipse ADT to Android Studio requires adapting to a new project structure, building system, and IDE functionality. To simplify the migration process, Android Studio provides an import tool so you can quickly transition your Eclipse ADT workspaces and ANT build scripts to Android Studio projects and Gradle-based build files. You can find more details about the migration process here. https://developer.android.com/sdk/installing/migrate.html. As you prepare to migrate from Eclipse to Android, you need to be aware of the fact that Android Studio contains different project file structures, manifest settings, dependencies, and so on. This requires that you change some dependencies and some manifest settings. Let's do this now by migrating a project developed in Eclipse to Android Studio. Click on Import Project. Select the project location. Confirm the destination directory. Confirm the changes while migrating a project from Eclipse to Android Studio. Generating a build will take some time, so wait for it to complete. Now we can see the Eclipse project has been successfully migrated into Android Studio. It will provide any import summary where you can see the details of the migration process such as ignored files, replace jars with dependencies, move files, etc. Android Studio is made up of three main components: project and file structure, Android build system, debugging and performance. We are going to discuss each of these in detail. By default, Android Studio displays your project files in the Android project view. We can see that here. If you recall, we just created our weather app in Android Studio. In the left panel, click on Project and it will show the project structure. At the top we can see it is showing the default Android project view. We can select either project view or package view, etc. By default, Android Studio will display your project in Android project view. Let's discuss this in more detail. In Android Studio, a project encapsulates all of your source code, libraries, and build instructions into a single organizational interface. Everything you do in Android Studio is done within the context of the project. A project defines a number of collections known as modules and libraries. Depending on the logical and functional requirements of the project, you can create a single module or a multi-module project. Your app is a module and Gradle scripts contain the build instructions to run the app. Let's open the app folder. It contains three items: Project Manifest, Java, and Resource. Android Manifest is where the manifest files are stored. Java contains all the source code for the weather app. Here we have the source code for the app and the text units for the app itself. Res or resource folder contains all the layouts, drawable resources, etc., which are used within the app. Gradle scripts contain the scripts that are needed to build the project. We have basically two Gradle files, one for the weather app and the other for the module app. We will discuss these in more detail as we go. Now let's move on to the Android build system. The Android build system is the toolkit you use to build, test, run, and package your apps. This build system replaces the Ant system used by Eclipse ADT. It consists of an Android plugin for Gradle. Gradle is a build automation tool that builds upon the concepts of Apache Ant and Apache Maven. The Gradle script contains the instructions that are needed to run the application. In most cases, we only need to edit the build files at the module level, i.e., build.gradle of module app. Let's look at a few key parts of the Gradle file. Apply plugin com.android.application. This applies to the Android plugin for Gradle execution. Android Element, which is available for specific Android devices. Android configures all the Android-specific build options, such as Compile SDK version. This property specifies the compilation. Build Tools version. This property specifies what version of the build is to be used. Default config. This property configures the core settings that are in the manifest file. It can have application ID, min SDK version, i.e. the minimum SDK version on which the app will run, target SDK version, i.e. the SDK version that we are using to build the app, version code, version name, build types elements, which control how to generate the builds and packages for the app, dependencies elements, which are outside and after the Android element. This element declares the dependencies for this module. We will be going through each of these elements in detail. Android Studio provides a number of improvements to assist you in debugging and improving the performance of your code, including improved virtual device management, inline debugging, and performance analysis tools. The AVD Manager provides a graphical user interface in which you can create and manage Android Virtual Devices, or AVDs. If you recall, AVDs are virtual mobile devices that run on your computer, thereby eliminating the need to have a physical mobile device for testing. AVDs are required by the Android emulator. AVD Manager has up-to-date screens with links to help you select the most popular device configurations, screen sizes, and resolutions for your app previews. This is an extremely useful add-on that you get in Android Studio. Let's apply what we just learned. Let's create an Android virtual device and run it. Open AVD Manager in Android Studio from Tools, Android, AVD Manager. This is the interface that we use to create virtual devices. Click on Create a Virtual Device. Let's select a popular device, the Nexus 6, and click Next. We can see the device details with SDK versions, etc. We can give the virtual device a custom name, say Nexus 6 _ training, and then finish the steps. Now we have successfully created a virtual device. Click on the play button to run the device. In this case, you will see that there is an error. HAXM is required for running 86 system images. This is one that you may face when running the AVD for the first time. It only happens in certain cases. In order to resolve it, you will have to tweak some settings. Go to Android SDK, Extras, Intel, Hardware _ Accelerated _ Execution _ Manager folder, and click on the file name Intel HAXM-Android. It will ask you to install software powered by Intel Software Tools. Once the installation is complete, go to Android Studio and try to run the virtual Nexus 6 device again. Now it should run smoothly and will open the simulator view of Nexus 6 on your screen. It is important to remember that this is a virtual simulation and it won't run as well as the original. In this case, transitions won't be as smooth as on the physical Nexus 6. Now we can run our app on our virtual Nexus 6 simulator. Within Android Studio, click on the play button on the app menu. You can see Gradle executing tasks and the progress is displayed at the bottom of the screen. A screen will pop up and it will allow you to select the virtual device to be launched at this time. This will be useful when you have created a number of virtual devices for the same app for testing purposes. We'll select our Nexus 6 training device. You can see the log messages in the console. This is the application building to load on the virtual device. The device will be loaded with the app that we have just created. Since we have just created the app and loaded it on the virtual device, a test page with a Hello World message is shown for now. We will add more code in the coming sessions to make the app more functional. Android Device Monitor is a standalone tool that provides a graphical user interface for several Android application debugging and analysis tools. To start Device Monitor, from Android Studio, choose Tools, Android, Device Monitor, or click the Android Device Monitor icon, or from the command line in the SDK Tools/Directory, enter the command Monitor. Start an Android emulator or connect an Android device via USB cable and connect Device Monitor to the device by selecting it in the Devices window. Android Studio comes with inline debugging to enhance your code walkthroughs in the debugger view with inline verification of references, expressions, and variable values. Inline debugging information includes inline variable values, referring objects that reference a selected object, method return values, lambda and operator expressions, tooltip values. We will discuss debugging while developing our app in the upcoming sessions. Android Studio comes up with different performance analysis tools such as memory and CPU monitor, data file access, code inspections, dynamic layout preview, and log messages. These profiling tools help you to analyze the efficiency of your app code. They allow you to record and visualize the rendering, compute, memory, and battery performance of your app. This concludes our discussion of the Android Studio, tools, and creating the weather app.